So up until now, we've been using the Phoenix channel. We have a space channel to receive messages. So when the front end wants to communicate with back end, we can use channel push, and then the front end can also listen to channel on and some string, some event to process some message from the server. So we can communicate with that. And the type of message we've been sending is, I created a type called a command. And that kind of has this structure. So it has an entity ID, which is some string, and it has optionally something you want to set. So this is a component and value. So you can have a component name like position, which could have been some array of numbers, a rotation, which is something like that. So it makes it convenient to update pieces of data. And we're using this for saying that I'm here. So we want to have this concept of presence, which is to say I'm here, or I've left, I'm not here, and I've moved. So this is kind of what I mean by presence. You're either here or not. And if you are here, like, where are you? What's your position and rotation? And we can do this with a command. So we can, if you're here, the here can kind of look like, well, entity ID will be your unique user, which we made in a previous video. So every browser session will give you a unique ID. So it's your member ID. And then we can say, I'm going to set something called the avatar. And maybe the avatar contains a URL about the type of model you're using. Right now, I'm just hard coding everything to box. So everybody's just a box. And if you've left, we'll just remove this entity. So again, your member ID. And we can delete any list of components. The one we want to delete is avatar. It kind of doesn't make sense to just delete the avatar because there are no other so if we received this kind of message, we could in the front end draw a box. If we check that there is a delete in a message and it is avatar, then we know to delete here. But we actually want to delete the whole entity, so we can set the TTL, the time to live on it, to 0. The reason why this by itself isn't a good way to check is because you can have a TTL on some other kind of entity that isn't related to it, and we'd have to check all the components. Whereas this is easier for us to say, oh, this is the particular component that is going to control the presence of that box. And then I've moved can be another component altogether. That can be an entity ID of member ID. And then we'll set your pose. So that can be an avatar pose, which inside right now we can just have the head be position and rotation, but then later we can also add like your left hand could have position, rotation, etc. So there's more to be expanded on that. So we can kind of achieve this with just commands. But we might be able to assert this message when we join a space. Remember, we have to click a button to enter. So we could send that message when we're entering the space. Just send this command. Say, everybody, I'm here. However, we won't be able to send this one because if we just close the browser, then we're disconnected. We've stopped having the ability to send any messages, so we won't be able to send this. So I've decided that both of these messages will just be sent by the server instead, and we'll use the Phoenix.Presence technology to do that. So Phoenix has a built-in mechanism, or a simple way to track whether you're connected. So I'll really quickly go through that. We just have to create a module called the presence, in which case we use Phoenix.Presence, and all of this is in the documentation. And having this presence module, you need to add it to the application. So in the supervisor's children, we're adding this. And then finally, in the space channel, which will get called when we join the channel. So when we click this thing, we're joining the channel, which will invoke this join function here. And we send ourselves, since this is a gen server, we send ourselves a message called after join, and we handle it here. And I have some extra logic here that I wrote off screen, which is a little extra stuff right now I don't want to get into, but this is the important part related to the Phoenix tracking. Is here we track that this process is alive, and as long as this process is alive, then we are present. So presence track, give it your unique ID and some little bits of extra information, which we don't really need this, but we're just saying, hey, I'm here. And if this space channel dies, which will happen if you close this tab, then Phoenix Tracker will automatically send through the pub sub joins and leaves. So it'll say you left, which we don't really need to handle that message. It's sending that messages, but we have our own way, because again, we want the message in this format. This is the system that we're adopting, universal system for all of the things. Everything is an entity. Everything has components on it. So with the Phoenix tracking, this module, you can also add this special callback called the handle metas, which is called with the joins and leaves. And so I convert that join to a, as you can see here, a command, and I'm pushing that message somewhere. Where I'm pushing this, I will go over in a future video, but essentially I have a destination called a manager, which will process all of the events. And here, if you leave, if there's any leaves here, we'll loop through those and we'll create the delete message. And these will get broadcast to all the connected browsers, and then we achieve the same effect. So now we're able to get this as before, except we don't generate this in the front end, and we're able to capture this when we leave. And yeah, and furthermore, in the space channel, we're also processing movement. So we're sending movement events, and we're sending that to the manager as well. So you can think of this as an event stream. All of these messages are coming through to some destination, and that thing is broadcasting them. So that is essentially it. Let's do the demo. So here we have a tab on the left, and I'm going to open an incognito on the right, going to the same place. I need to use incognito because the way we did the unique member ID is tied to the cookie. So if we open it up without going into incognito, they would be sharing the same member ID. Here I log in on the left, and I'm going to push forward so that my position is different, because both of these are going to start up at the origin. So I'm going to go past this sphere a little bit on the right. I'm intersecting the cube right now. So if I enter on this tab, we should see the person on the left. We enter here, and there we see them. And if we push forward, you can see we're seeing that movement. And if I turn all the way around, we'll be able to see this person over here. And if this person moves, shakes their head up and down, you see that we're sending a flurry of these messages. I moved, and the fact that as soon as you came in and you saw the other person means that we're syncing up that position through the Phoenix channels. So here's the broker where we're handling the present state. which we pushed from space channel. As soon as we joined in the after join, we pushed the presence state and we give it a presence list, which is a map of key to these values, and so we really just need the keys, which are all the member IDs. So in the broker, we broke that down into this message here, just to get us started, because although we are translating joins and leaves as these come in, if you've got 10 people in there already and the 11th person join in, you're only going to get a leave, or sorry, a join for yourself. You're not going to get any leaves, so you wouldn't be able to draw the prior 10 people that are there. That's why we send this present state that gives us all 11 people that are in the room, and that'll allow a 11th person to draw everybody. And so that's what we're doing in this broker. So we need one present state here. Otherwise, all the other messages are coming through the mechanism that we had defined before, which is just server to client, which is handling all the messages that we're sending via this command-like pattern. All right, so this was just about using Phoenix.Presence, transforming the message into the sort of schema that we've adopted for everything that's happening in our space in order to have the best of both worlds. We don't have to implement, we can take advantage of the Phoenix.Presence, the way it handles the joins and leaves, and adopt that to a uniform command schema that we have defined before.